Okay, let's continue on with our web application concepts. And we are going to talk today about the model view controller pattern. This is the design pattern of the web, if you will. The design pattern is not specific to the web. I'm giving you a reading out there that shows you this design pattern was written about, talked about even I think back in 1979 or 80 out of the Smalltalk community. It's kind of a general purpose pattern, particularly for user interfaces and partitioning your user-centric interaction modeling and user state changes from what's called your world model changes. But certainly really talked about with any web framework that you're going to use, no matter whether it's Node, whether it's front-end centric like Angular, whether it's Java, whether it's .NET, Ruby, Django. So the first thing you look for is how it realizes, or in other words, implements the MVC pattern. So I'm going to motivate the MVC pattern. I'm going to talk about the design pattern itself, and then we'll specifically take a look at what happens in Node, in particular using a framework called Express, which is probably certainly not the only, but probably the most popular of MVC style frameworks in Node.js. We'll talk in particular about the concepts of routes in Express and the notion of view templates. Okay, so the first thing conceptually is to talk about this principle of separation of concerns. And in talking about design patterns in general or software architecture, separation of concerns is a well-established principle. All right, it's not an architectural style itself. It's not a design pattern itself. It's an architectural principle. All right. And in separation of concerns in general, you talk about the notion of a concern being a category of responsibility of a system, a concern or a responsibility of a system that you want to have assigned onto some module, some part of your system. And the reason why I'm using such generic terms is it depends on the nature of the architecture of your system where that concern gets assigned. So for example, if you're doing component-based computing, like component container we talked about with servlets, you would assign that concern onto one or more components. Functional, it may be one or more packages. Systems-oriented with systems and subsystems or system of systems, you would find some subsystem to assign a responsibility. So that's the reason for the kind of the generic wording around it. In regards to web applications, there's typically three important concerns. I use the term aspect here. If you've heard of aspect-oriented programming, you've heard the term concern before, but I'm not going to go into that here. Our concern here is a responsibility of the system. And in web applications, we typically have three common concerns. The first one that you see listed there is data access, meaning we're dealing with some kind of, and we talked about this with server state, we're dealing with some kind of world model state, usually persistent in some database, persistent on the file system, persistent under some data source, right? Again, think of your web application as an adapter and your interaction model is a way of perhaps changing world state through some transaction on a database, let's say, some file manipulation, something like that. So you need kind of a layer that isn't, notice it doesn't say database directly, it says data access, something to abstract away the access to your data source or data sources, right? On the bottom, I'm going to skip down to the bottom and talk presentation. Presentation is how do we kind of abstract the input-output. Again, I talk about the web application as an adapter, as a wrapper, if you will, around that middle layer, that business logic. The presentation part defines how we're going to do input and output. In particular, the presentation defines how we get things out of our conceptual representation on the server, meaning our set of objects if we're doing object orientation, or the data we're manipulating via functions in the functional programming paradigm. We've talked about these things already. And getting them onto the glass, as they say in web application programming, meaning down into a rendered state so they show up in your browser. Okay, and there's a variety of presentation frameworks to deal with that as well. The middle one is the business logic. The business logic part, I mean, those are the core business rules associated with your organization. They are independent of your web application, meaning normally your business logic is shared across families of applications, web, mobile, desktop. are implemented in common. All right. Now, when you can abstract these concerns in your system and assign them into distinct, meaning things you can point at, modules in your system, you extract some great benefits. Some of those benefits are like anything from decoupling, right? The ability to vary the implementation of it. So let's say, my business logic is tightly coupled to my database and my data access, which historically has happened, where a lot of business rules will be implemented as database triggers, meaning on conclusion of a transaction, some other transaction, some other right to maintain data integrity would take place. Or perhaps tightly coupled in presentation, we saw that with CGI, right? We were writing the entire output stream and we generated some markup in the middle of it. Same thing with our SSIs and server-side scripts, right? We were mixing presentation and the actual business function of our application. So I couldn't use that for anything else other than the web, right? I mean, I was burying HTML markup into print stream statements. And so what would I use? I couldn't put that out, to a desktop application, right? I had to use something that was HTML viewer compatible to be able to render that screen. Decoupling of our code so we can vary implementation, so we can vary and modify, enhance, extend each layer independently. Data access layer, so I can vary. Maybe one day I'm using an Oracle database, the next day I want to use a MySQL database, the next day I want to use a Mongo database, the next day I want to use a file system. Can I create a data access API that is independent of those specific physical implementations that go on underneath? In fact, you can. From our perspective, where we're going to spend our time here is, we're going to really spend our time here. All right. In data access layer, there is something called the data access object pattern. It's historically, mostly equated to the Java stack. It actually really isn't. The ability to, and that's because of the object part, but the ability to abstract out a data access API, if you will, internally in your code, gives you that ability to vary your persistent store. That's not a topic for this course. That's a topic in follow-on in SCR 422. Because we're not really going to cover the database side in detail here. So we're going to focus on the relationship between the business logic and the presentation part. But realize it is important because these parts do roughly deal with what's called the model in our MVC pattern. Anyway, we're going to get to that in a minute. Again, me, I have a habit of getting a little bit ahead of myself. Let me clean, I guess I need to clean this up that much. I'm going to move on. So I want to do that. Oh, I'm sorry, one last point that was on here. It talks down here about these two important benefits of separation of concern. So on top of that, I kind of mentioned applying custom frameworks or being able to enhance each layer independently. On top of that, you can apply custom expertise, right? So this, if you factor out your presentation parts, this is where, for example, your graphic design people or your user experience people might live and exist. Whereas you may have, in a lot of larger organizations, you would have your service-oriented folks, if you've heard of service-oriented computing or service-oriented applications. Again, some we'll talk more about in 422. But what do those folks do? They're just implementing the business logic of your system. And here can be folks like your DBAs can work with your database administrators, can work with your database app folks to understand the best way to access the database from the business logic part, do that efficiently. So these separation of concerns have additional benefits for even how you organize teams, as well as the technology you might select to employ different frameworks here. Give you an idea of frameworks. If you are in a Java stack, you might be looking at an object relational management layer. A popular one in the Java stack is called Hibernate. There's another one called there's tons of these things. There's a couple of them right there. There are these things in the node and mean stack, right? Here, our data access layer might be talking to a Mongo database store, if you've seen the acronym mean. That stands for Mongo Express, which you're going to see today, Angular, and I know you can't read this now, and Node. Okay. In this class, then we're kind of talking about this guy and a little bit of this guy, but we won't talk about Mongo. We're not going to do the database part. But if Mongo's up here, you may have a data access layer here. So for example, you could be talking about something like Mongoose as your data access independent tier, something to give you that independence, if you will. On the presentation side, we'll talk in this presentation about two technologies, EJS and Jade. If you're on the Java stack, you could be doing XML, XSL rendering. You could be doing in the old days it was the T servlet. Now it's things like FreeMarker, Velocity. So again, I'm scribbling now all over the place, right, with different technologies and frameworks. And the point isn't the specific technology or framework. The point is I can vary and make my best of breed choice on each layer about each one of these and kind of mix and match to meet my requirements across my organization. The other part too to keep in mind is you have greater runtime deployment flexibility and optimizations. What does that mean? What that means is the computational profile, again I like to use that term, right? It means how much, when I say computational profile, I mean how much resource and what kind of resource does the computation use at runtime, when it's running in production. Again, we're thinking big time scalable servers, right? Big time scalable web applications running on servers. So what kind of memory do these things use? Well, I'm running out of colors, right? This layer right here is going to use a lot of bandwidth if they're running on different servers because you're moving a lot of data back and forth, presumably. This one, perhaps not so much. But however, the computational profile of your presentation layer historically is very memory intensive, but not so much CPU. So I can buy a different kind of server or rent a different kind of server if you're thinking cloud-wise in my presentation layer in order to do rendering, one where I configure the CPU and memory resources to be of a proper cost benefit and computational benefit that matches the computational profile. Same thing with your other non-functional requirements, your security requirements around these and so forth, can now be varied, again giving us that little dial on each one of these layers if we develop or create an N-tier architecture that kind of matches these concerns and we assign these responsibilities or concerns into those layers. Okay, so let's move forward and talk a little bit more about it. In fact, I've already just talked about the runtime deployment flexibility. And one thing, this is kind of and this is a really old article on Cold Fusion I grabbed this from, but part of the reason I put this diagram in the lower right up is for that thing I was talking about, that, and I'm underlining the word tier. Why am I doing that? You'll read, you could go out and read on the web umpteen numbers of blogs, and this kind of drives me crazy, where folks misuse the term tier. A tier is a physical layer that you can identify in a system. So what we're saying is that there is a tier or some workstation that are responsible for the presentation. There is a tier that is responsible for running your business logic. There's a tier for running your databases. And you hear the terms 3-tier sometimes and N-tier. One thing I want to make sure that you know this, because this is the kind of stuff that shows up on exam people. Model view controller that I'm going to talk about is not what we mean by N-tier. N-tier means you have a client layer, which is comprised of browsers. We have a web, you know what? This is going to be a complicated diagram, and I think I shouldn't be doing it on, I'm trying to write that in line on my slide. So let me bring up our notepad here. Oops, I brought up the wrong thing. That's the viewer. Let me bring up the notebook so I can do my scribbles that I know you love so much. So what I'm talking about is, and you've seen me draw what I call my favorite diagram before, but when we talk about tiers, what we talk about is I may have a bunch of browsers, right? I have a whole bunch of users around the world using different forms of browsers. And so this is our client tier, all right? These all make requests. They make requests over this nebulous thing we like to call the internet, all right? And then things get into our entry point in our system. So one tier that we have here is it hits our web servers. All right, I write this as a horizontally aligned array because usually we have one or more hosts or containers or cloud instances or whatever you call it to distribute this load so we can scale. Then these things are routed into, I've talked before, an application serving tier, where I have a set of application servers. For us, this would be the things running our node. All right, and then going even further, I'm going to go on to the next page. I go from my application servers that are running into a whole bunch of other services I may be talking to, all right, which may include a mail server. If I'm producing mail, it might be a social media server. But the most common one is to be talking to a database server or multiple of them, all right? And again, this is where you're this might be Mongo, this might be Oracle, or whatever, right? But in terms of tiers, this is a tier right here. This is a tier right here. All right, going back a page, this is a tier right here. And this is a tier down here. So just there I wrote a 4-tier network, all right? Or network, 4-tier system, if you will, as my approach to partitioning system responsibilities across a physical architecture, meaning each one of these boxes I drew, that's a computer somewhere. This is a computer process, right? Some program running somewhere. They're all individual processes running presumably on individual computers somewhere, okay? So that's what the term tier is meant, all right? Tiers do not equate to model view controller, which I'm going to talk about in a second. So let me clear this up, and you can keep in mind those scribbles, and again, I'll save and post those. All right. Historically, as I mentioned before, the layers, these tiers, were very incestuous, meaning coupled. This just means coupled. All right. So business rules will be in a database with stored procedures, or as database triggers, or in long SQL queries, or God bless you if you work with COBOL. I have a kind of thing. So along comes for the web. Again, a little bit of history. The web comes about, and the whole ability to reuse or adapt the web for legacy applications. The initial ones were legacy applications running on mainframes. So dealing with that integration and trying to keep that coupled. But over time, folks have come and started writing their business logic on more service-oriented architectures and tiers. They've broken down the mainframe, made it more service-oriented or component-oriented. Again, that whole service-oriented computing thing isn't really what this class is about. 422 does that. But the point being is, by doing so, it gave us an ability to kind of refactor and rethink and apply an existing pattern called model view controller to the notion of web applications. All right. So keep in mind, this is a design pattern, as was talked about in SCR 316. It is not the same as separation of concerns. Separation of concerns is an organizing principle, an architectural principle, all right, for assigning responsibilities of a system. It's not N-tier like I just talked about. N-tier is your physical layers, if you will, of a system. Where the machines are and where the processes running on the machines are, all right? This is a design pattern, all right? What's a design pattern, as we've talked about, right? It's a solution to a problem in a context. This context is MVC for the web. In that case, the parts of this pattern, the view is the presentation part, meaning the view supports the separation of concerns principle of presentation. The model comes from data sources, so back in tiers it comes from these databases and file systems and so forth. At least that's where the information is. The model is also going to include the business logic. So the controller in the MVC pattern is not the business logic. In fact, when it comes to the controller part of the MVC pattern, there was really no equivalent on this separation of concerns diagram. What we're saying here is that up here, I would have stuff related to the model would be kind of encompassing here, and the view would equate to here, but there's nowhere on here that the controller exists. And I say that because, again, you'll read some stuff, you go on a blog, you can get an argument with somebody, and they'll try and tell you that the controller is the business logic. I'm here to tell you it's not. All right, we're going to talk exactly about what a controller is and why it exists and why it is very important for web application programming, but it is not the business logic of the separation of concerns principle. All right, so let's go forward and talk about this in specific detail. Model view controller, what is it? Again, it's the design pattern of the web. It's a reusable solution in a context, the context here being our web application. So think of our 6 steps, right? Our 6 steps back to the Node HTTP lecture. All right, I'll give you a minute to think about it. Right? What was step 1? We deal with the request headers. What was step 2? We deal with the request params. Step 3 was route or delegate to a handler of sorts. Right? Assemble a response. Assemble the payload of the response. Right? Get the response headers. Set those and write the response. All right? Those are the 6 steps that we were talking about. Our 6 steps. That's the context. So what MVC is trying to do is to help you organize these things. All right, that's what we mean by that. The reusable solution in this context, the framework, will have 6 steps as well. They're both 6, but they are not the same. There's not a one-to-one equation here. So we are going to talk about what the steps in the model view controller, what these 6 principles are. These are 6 steps of the template pattern, if you remember, from those notes, and then there's going to be 6 parts that we're going to talk about with the MVC structure. The MVC, yes, it is an organizing principle. It's going to tell us where things go in our code. Therefore, I consider it a structural pattern. Now, again, if you thought of design patterns back to the Gang of 4 book, as was talked about in SCR 316, all of those are object-oriented patterns. So when we talked about structural, basically the structural patterns are represented by the class diagram you saw with each of these Gang of 4 patterns. Now, yes, JavaScript's object-oriented, we've talked about that, but we're essentially doing a functional programming paradigm. So this is structural, but this is going to be, for Node at least, with Express, it's going to be how we organize our functions. All right? So if you've been wondering, well, how do I kind of organize my code around a web application? So I kind of know where things are, and I know how to extend and grow my code in some reasonable, logical way. Well, MVC is here to help. NodeExpress is going to be here to help. Okay, so we'll see that. A little bit of history. I actually mentioned this on the first part of the slide, but please look on the reading list for this paper that talks about the Thing Model View Editor, because I would really like you to read that history. To have an idea of how MVC started and how it started, 15 plus some odd years before the web. All right. Drilling down more with history, I'm going to fast forward again to MVC as it exists in the Java framework. When MVC became really the popular discussion around applying MVC in the web came with the Java stack. Again, this was all early 2000s kinds of stuff. But as folks started to try and wrote more and more code and had homegrown frameworks, and the first web application frameworks were coming about. All right, in this world, in the Java world, what happened is, and I talked before about our component container computing, and you had this. Again, let me not scribble pictures on the slides. Let me try and get another page here. Well, what happened was we had and again, I know this class isn't about serverless technology, but I am trying to explain to you a bit of the history. We had HTTP and we had the evolution of CGIs and so forth we talked about. And the servlet API came about and gave a nice wrapper layer, so low-level programmers didn't have to write and rewrite all this HTTP stuff themselves. So it gives you, just like in Node, it would have in the HTTP model. This is roughly equivalent, this low-level API, at a very crude level to the Node HTTP module that I made that we discussed and I made you write a program in, right? This HTTP module gives you very low-level access to the request object, the response object, the query string, and the URL, and these kinds of things as part of the protocol. Well, Servlet API does the same thing for Java. Either one you're talking about, the issue is there's still a level of abstraction you're craving for, right? There's a level of convenience as well as an organizing principle. I mean, the Servlet API, the Node HTTP API, neither of these things give you an organizing principle. Neither of these things really got rid of redundant work for you. So what happened was over time, folks started writing their own homegrown frameworks. In fact, when you look at the proliferation of NPM modules, it's people still write their own frameworks. There's particular requirements, there's particular organizing principles that seem to make sense for them, and so they write their own framework around it. So I still see servlet frameworks coming about, and there's certainly plenty of Node frameworks that are coming about every day. By all means, it isn't like Express is the one way to do things, even if that's what you see the most books on. There's other ones, for example, Happy.js and so forth, that come about. But folks, homegrown meaning within an organization, people were doing this, and then they were going to developer conferences like Java 1, like an open source development conference, like a professional development conference, and starting to share, these best practices that we talk about. The best practices are, emerging ways of thinking about things that come out of the developer community. So basically, these homegrown frameworks turned into reusable frameworks. All right, and in the Java side, you started the first major one with something called struts. There's hundreds of these things we could talk about. There was JSF. Well, fast forward to today, probably the predominant one is Spring, and actually a sub part of Spring because Spring's quite expansive. Whereas on the Node side, as I said, there are these other ones, reusable frameworks. We're going to talk about Express. There's Happy.js, and there's, again, a boatload of these additional ones coming about. These reusable frameworks then are going to provide for you convenience APIs, meaning you're going to be able to work with the same low-level stuff you saw down here at the low level here, but in an even easier to use API than what's provided in that low-level part, working with requests and responses and things from the protocol and the like. Things with cookies, right? Cookies in raw HTTP meant you had to manipulate the request and response headers yourself and so forth. Well, now you're going to see you have these cookie API available to you. They provided a way to extend, a more logical way to extend things in a uniform way. In Node.js, we're going to talk about that next time. It's called middleware. All right, so we'll talk about that. So these kinds of, this kind of layering, this kind of continued evolution of frameworks is intended to express, if you will, pardon the pun, the best practices of the developer community. But the conceptual foundations are the same. Going back to this, conceptual foundations are the same. An organizing principle around a design pattern called MVC to address an architectural principle called separation of concerns. Okay, so this was what happened. Again, back to I started off on that tangent because I started talking about what happened in the Java community. Java community started about with something called the Model 1 pattern, and then evolved it into something called the Model 2 pattern. I won't that whole history I won't bore you with, but this was in fact, you can Google. I can post out of the Java J2E committee. I'm guessing 2001, but I'd have to look it up. What happened in that community is you basically came up with this 5-step, or I've talked about 6 steps, but in this case we're talking 5-step process where a browser request would come in to a special component, our servlet. That servlet would basically take the request and plug into the models. This whole box over here where we have that data store, database I was talking about, and the business logic is here. That's why I said on that previous slide when I was getting sloppy scribbling that the model comprises the data store and the business logic, and you have some interface point into that. What happens is you basically instantiated what were called Java beans at the time, objects here, a projection of your world model that you could then execute or translate as a result of the business logic execution, and then the controller server would forward, do what's called a forward onto a view technology, in which case this would be JSPs. JSPs were a reaction to Microsoft ASPs. You could also do this via as I said, other things here were templates, XML, XSL, all right, this kind of history, all right. That would read data off the objects and generate the response, all right. So the 6 parts of what we did, all right, if you go back to, again, here's what I'm going to do for you. This part up here in red, remember from our HP, oh, I didn't mean to grab and drag that. That was interesting. Let me try not to do that. All right, this 1, 2, 3, 4, 5, 6. All right, let me show you where that exists over here. Basically, the request comes in, and 1 and 2 would happen inside the controller server. I mean, the controller server had the responsibility to look at the request headers. To look at the request headers, it would do what's called marshalling. Marshalling means translating those into a set of objects, all right, and then passing all that along to do this part. It also did step 3. This here is our step 3 back here, all right, routing or delegating to a handler. Basically, we'll go in and say, okay, you're going to delegate and find some entry point into the business logic and do your stuff. All this happens, by the way, on its own. It's not part of our 1 through 6 at all. This is the, in a sense, you could consider this the black box that once we get out of WebLAN, this is all stuff that's shared by any interface that you want. Mobile, desktop, command line, client, whatever, all right? Our web as adapter means that's kind of a border right there, okay? Now, business logic executes, returns a result, comes back in this case. Now we have to go forward and do step 4, which is assemble the response. 4 is the responsibility of the view, gets forwarded to it. Let me write it in red to try and stay somewhat consistent. We have to assemble the pipe, the payload. We have to set the headers, and then 6, we've got to write the response out. All right. So when you look at these steps of the template pattern and map them onto that architectural principle, that's roughly how it would go. All right. Now, again, I know we're not doing server technology in this particular instance of the course, but the point is the same. We've got to do those 6 things around our MVC organizing principle, and MVC is going to help us with that because even in a functional paradigm, MVC is going to exist. Okay. All right, and that's so. This is what I'm talking about. Now there are 6. These are the 6 steps I was talking about that are different. That again, don't get confused. This part of MVC with 6 part here of the template pattern we talked about. Meaning and again, remember we talked about this as the rendering pipeline, the steps that all web applications have to go through to get something out, a response out to the screen. All right. So this is MVC, distinct from the rendering pipeline template pattern. Okay. So let's not get those things confused. Okay. So again, first thing, the request comes into a controller. Controller routes or delegates that to the model. The model does its magic, the business logic, that's the black box I was talking about. Controller identifies the appropriate view, meaning it knows how to also not just route into the model, but it routes to the right view. The right template or template in a generic sense, template, XML, XSL, function, whatever it's going to use to actually put things on the screen. The view then accesses the results, really the projection of the model, meaning the results that will come out of out of this step to get the dynamic output and then produces the final rendered response in the browser. All right. So again, I just did that comparison for you. In that comparison, by the way, just so you know, the model executing the business logic, that's the strategy part. That's how you delegate into the handler. So that's how those things kind of line up, if you will. And that's something I would like you to be aware of, is organizing principle MVC pattern versus the 6 steps of the rendering pipeline that you apply in this kind of template plus strategy pattern format. And I want you to understand both of them, how they relate to each other, but also how they are distinct from each other. Okay. As we're 35 minutes in, I'm actually going to stop this video now so it's all digestible, and I will now run into Express and how it realizes the MVC pattern next.